And if so when the Zoom emails you, it says, "Please send me a copy of link."
Yeah, I was like, that's good spring.
You guys don't remember that question?
Yeah.
You know, who came up with your math for all logo?
In person, yes. Yeah, try to shoot before, I think it's gonna be.
Actually, my balance sheet was not bad.
When is the? Oh, I understand. Which, you know, I like it, like YouTube competitors. Oh, yeah, I just saw that. I didn't think. Because I heard something about Twitch later, and I'm not sure this.
Yeah. Oh, okay. Is that you were asking? Oh, well, this is
I came in, so they had like a 2 o'clock game, maybe, 2 or 3 o'clock. Anyway, I've been here like a couple years, but I didn't know all the ins and outs. I came in on Saturday.
I always
and
call it-
Saturday, right, like 11. It was like a gold bar. I came out, my car was gone. You talk about being, yeah, it's stalled. Oh, yeah, yeah, you know, you know, so what they say is that they can tow you up to 12 hours.
Oh,
The
right.
game, when technically, I think kickoffs is noon, so they'd be at midnight. Although I doubt they'd be that rapid about it, but. Do you know who we play? Not just the next game? Yeah, you don't know her. Yeah, cause I'm trying to remember. I've got a visitor coming in town. He's having a hard time getting those. It must be a home game. I mean, this is Notre Dame. And I don't even know.
I think everyone likes the pizza. Like they keep growing up. From me, I like the pizza there, but everyone likes their home pizza. Yeah.
All right.
That's where I live.
Okay, folks, thanks for turning out. Help yourself to pizza and all. It is always a pleasure to welcome Keisha Cook to speak to us, and she is going to tell us about scientific research project.
Thank you for having me. I'm always happy to talk to Math Club. Thanks, Jim, for the invite as usual. So first, I'm going to talk a little bit about the conference, and then these skills, of course, are transferable to any conference that you go to. So it's a good thing because I had some grad students who have never done a poster presentation before, and just walking them through the steps and giving them the template and kind of, just having an office hour about this is the same thing which I will talk to you today about. And so I have some slides, some information, of course. Feel free to ask questions throughout. You don't have to wait to the end. So if you have a question, just raise your hand. I'll acknowledge. And if you do, so I will have this email list later, but if you want information about the conference, which is not until April, you can add your name to the email list, just a Google form there, and we can give you conference information later. But again, these skills are transferable to any conference that you attend. And there's also a QR code if you didn't want to write that down. But the Math for All conference these are the goals of the Math for All in New Orleans, technically conference, but it's called that because it was started at Tulane University in 2020. And the goal was to create a welcoming environment for undergrad students to get involved in the research community at their own institution before actually going out to the big conferences, like joint math meetings, the big science annual meetings and things like that. But how do you actually get into the research community without being thrown into the mix and, just learning all these skills with your faculty at the university, grad students, and just mixing everyone at the age of undergrads. And so having everybody, all the tiers, all the levels involved in this conference, and additionally, having it with the neighboring universities, because this is in New Orleans, it's really small, it's a smaller city, but there are maybe 4 or 5 institutions there, and there's no collaboration between them, and there's only a couple miles apart. So the idea was to have the conference in Tulane and then spread it throughout the neighboring institutions. So also fostering collaboration between different research levels at your institutions. And now we have, so 4 years later, we are doing this satellite based. And so the majority of us, we were at Tulane at the time, I was a postdoc, and now there are faculty members, some of the grad students are now postdocs and faculty at other institutions as well, but we wanted to keep the conference going, and we have NSF funding, so we have to keep it going. And so the idea was to now spread this to the universities that we are all at currently. And so still housed in person at Tulane, but we also have local conferences here. So we'll have one here April 5th and 6th. And we'll have a local speaker, and then we'll watch some of the live plenaries that will be happening at Tulane, but we'll have our own local schedule. We invited and sent out the invites also to neighboring institutions. I know they're not very close in Clemson, near Clemson, but South Carolina, Tennessee, North Carolina, but hopefully last year we had a couple of students come from other universities, and we did, maybe kind of small for those in the back, but we did activities such as Math Jeopardy. We had poster sessions, short talks. We did lightning talks last year, so those were just like 5-minute talks for those who are just getting into the research area, wanted to kind of share what they were thinking about, or maybe they were finishing their PhD and they're like, here's my elevator pitch for when I go to interviews and things like that. Those are the same type of activities that we'll do this year. So this is just a general overview of what we'll be doing. This is all again on the QR code. If you go to the website, you click on the Clemson satellite and we'll have our schedule. But the speakers are already noted as well. And so this year we'll have Anna Nelson. So it's one of actually my collaborators at Duke University, and she's in math bio and does some work with some cool programs for minority women in math programs. So she'll be here on campus to give a plenary address, and then we'll have the others on Zoom live in the space. Okay. So this was the first year at Clemson with us, and I see a couple of people that were there, so thank you. But we had the opening, so this last picture was actually a Wikipedia edit-a-thon, so we spent some time, maybe an hour, 2 hours, editing and adding mathematicians to Wikipedia. So not necessarily your most notable or your top mathematicians, but even mathematicians who are just getting started and making sure that their name is out there as well. So it was really fun. That was our hands-on activity for that year. And then last year, we played Math Jeopardy, and so those were the winners for Math Jeopardy. We kind of mixed it up between pure and applied questions, just random questions, and played for a cookie cake that says you're one smart cookie. And yeah, so this was last year. And again, familiar faces, so thank you. But we had maybe 4 students from other institutions, and they were all to Virginia and North Carolina. So that was pretty cool to have them mix and mingle with the students here. But to get to the poster session, this is what you would normally expect when you see a poster session. So at a big conference, there's many, many more people. So you would have a big room with your poster set up. You are standing in front of your poster for 30, 45 minutes. People are coming by talking to you. They may have short questions, and they have in-depth discussions with you. They may give you feedback, ideas, something that you may not have thought of. But then you also have time to walk around to other posters and then talk with other students, see, collaborate, network, all of the above at these poster sessions. And then here's another example. I know Jim, you were just asking who developed the logo for the Math for All. That was Addie in the top right, so she developed that. But this was the poster session as well. And it's just it's a good time to talk about research at any level. So if you're just starting, having a poster that doesn't have to have a whole lot of information, but maybe background information, maybe preliminary ideas, what you have used in your coursework that is interesting to you, a question that is exploratory, and what has been done. And if you are further along in your career, maybe you're finishing your PhD, or maybe you're a postdoc or a faculty and you're doing a poster presentation, it can still be summarized to this poster, but giving the main idea, or maybe you're focusing on one portion of your big project. But again, poster sessions are relevant for all stages of your mathematical career. So finding and choosing a topic, and this is different at different levels, right? So if you're an undergrad, maybe you're just getting into research, or you want to figure out what math research is like, and maybe your professor in your math class has a problem that they applied problem or something of that nature that you're interested in, or they mention, oh, this has not been proved, or they say this is a topic of interest in research or something of that nature. But you go to the professor and you say, so I was talking, or you mentioned this in class, so what can we do at my level now to kind of explore that topic or that question? So that comes with meeting with individually with your faculty, now becoming your faculty mentor, but at that point, your professor, expanding on some of the assignments that they maybe assign in class, or intersections of math with another discipline. So if you're like a double major, for instance, and maybe you're in math and engineering minor, and there's an engineering question, and you're like, oh, well, technically I'm a math major, I'm taking some engineering courses, but if there's something research-wise in the middle that I can do, that's interesting for poster presentations. But finding and choosing your topic. If you're a grad student, you're probably interested in working with some specific faculty member, and that is going to be related to your dissertation or your master's project or your dissertation. And your poster would be around that topic, or maybe one piece of that. Like I mentioned, if you're PhD, you have multiple roads that you could take for those couple years of research that you'll be doing. But either way, you have interesting topics to talk about. If you are getting started, here are a couple of places just to look for inspiration, and that is a journal. There's a couple of websites here. I mentioned your professor's website, and some Google Scholar and archive websites as well. So these are usually exploratory problems. They're at different levels, so you can really look at what level these different websites are geared towards to see what kind of problem you may be interested in. And again, it doesn't have to be something that's long-term, especially if you're just doing it maybe for the Math for All conference. You just want experience. What is math research? So can I answer a question in a couple of months and present it in a scientific manner, right? So that being some ideas, some places that you can look for inspiration for these project topics. Right? Good questions yet? Right. So I mentioned talking to your professor, but what if you're not in their course? Maybe you are looking through the Clemson website and you see some topics that you're interested in. Maybe they're in abstract algebra and you do that something. I know what Dr. Carter does. She does cryptography, so maybe you're interested in that. And you're like, well, I haven't had her, but I want to send her an email and I'm kind of interested in this, so maybe I could do a poster presentation for this work and see where we can go with this. So here's just a sample email that you may, you can fix this up and format it the way you would like, but just some ideas. And because anytime you reach out to anyone that's a researcher, you just want to make sure you have a goal in mind, so you're not just sending a blank email and so I'm interested in working with you on topology, and they have no idea where to go from there except having a meeting. So just a little bit of where your ideas are coming from, why you're doing this, are you presenting obviously a poster at a poster session, and then of course talking with other students undergrads, grad students, and maybe the postdocs as well, but finding out who's in a research area that you are interested in, and then going from there to figure out who to reach out to, especially when you're just getting started with research and you're not really sure what to do or where to go. And I'll send these slides to Jim to share afterwards. Okay. Oh, and one other thing I meant to mention here, the mentors or collaborators, these can, of course, if you're just getting started, you may not have mentors or collaborators, but talk with other people to figure out who are good mentors, because good mentors will point you in the right direction, regardless of the fact that you're interested in their research or not. But collaborators, if you're at the grad level or postdocs, etc. But these collaborators, again, can help you generate more ideas, but then also find people to work with that may help you in a different way. Yeah.
And I think it's important to point out that if you reach out to somebody and they are too busy or whatever, you should not let that knock you off your horse.
Yeah.
Right, so don't ever let that discourage you, because sometimes the timing is just not right, and people are sometimes involved in many students, so.
Yeah, that's a good point. Right, so how should you design a poster? There's a couple of templates, so I will get to that on the next couple pages, but you want to have some major title, of course, and that title needs to be, yes, about your research, but when people are walking around, you want to think, what will attract them to my poster, right? So what is your, it doesn't need to be something that's super long, with maybe a bunch of things that people may not know what it means. So not super detailed either, but it needs to be broad enough, but in the direction of your project topic, right? And that title will, again, just draw people in. But then underneath the title, you'll have your subtitles, those are the blue ones, but you want to make sure that you're reading this from left to right. So starting at this first section here with, and I'll get to that on the next slide, but maybe background or introduction, or maybe some preliminary things that are known in the research currently. But then going through this in your first column, and then moving on to your second and third column are usually, or they can be combined, maybe just 3 columns, depending on how much spacing you need. But the middle columns are usually what you're working on currently, and talking about the steps that you've taken to get some results. You don't have to have all the results, of course. It can be preliminary, even if you don't have quote unquote results. Maybe you just want to talk about some discussion. So what have you found based off what you've done? And all of that is in your last column in column 4. So discussion-based results, future work, things that you're thinking of. But again, it does not have to be complete to make when you're giving a poster presentation. Anything that you put work towards is actually something towards that research. So just keep that in mind whenever you're doing research at any level. You know, some of the projects I've been working on now are going on year 3. Like, man, that's a long time, but it's progress. And there's different reasons for that progress being fast or slow. Maybe it's a harder question, maybe it's a easier question, or maybe you have collaborators and they're slower on their part, so you're just waiting back and forth. There's all kinds of different things that happen when you're doing research. So don't let your progress deter you from presenting it. Dimensions, usually about 48 by 36. Usually long ways is best. I probably see this more often than not. Some people do the long way and they have 2 columns. You just have to kind of squeeze everything differently. But if you do 2 columns, you know that works. Maybe you have a lot of figures and things that are better, bigger. But either way, 48 by 36 in either direction is usually how you want to view your poster. And usually when you go to a conference, they have like a piece of cardboard exactly that size that you attach it to. So it works. And nowadays they have canvas ones, so you can roll it up and put it in your suitcase, or they have the tubes that you can get at Staples. I was gonna say Starbucks because I just went to Starbucks earlier, but it's Staples. And stick it in the tube, and then it's safe until you get to the poster session. All right. So how do you design a poster? you want to make sure it's readable, right? People are coming by, you captured their attention by your title. Now you want to make sure they can read it. So here are just some standard fonts that are good for posters, because they can be seen again from a distance and at smaller sizes, but you don't want it too small. Usually on your poster, you want at most 2 fonts, and that's just because there's going to be a lot of information out there, right? So you just want to keep it, again, readable, and not too small and not too bulky, because you're going to be talking about your presentation, your work, but at the same time, whoever's standing there is going to be reading. So you don't want to be reading off your poster, but they'll be reading. Okay. And then you want to make sure it's bold, italicized, underlined, the things that you want to emphasize, and maybe that can even be a hint for you. So like I mentioned, you don't want to put everything you're going to say on your poster. You want to not highlight the most important, but you want to put summarizing statements on your poster, and then maybe underline the pieces or a word or a definition, something that you're going to talk about more. So then when you see that on your poster, you're like, okay, this is what I needed to emphasize while I'm talking. So those bold and italicized and underlined texts are actually a hint for you and the reader that this is important for this research, or this is an important piece of the research. All right, so how should you design the poster? So I mentioned this when we were looking at that first slide, but again, so I went through these. You have your abstract. So I actually skipped abstract. So your abstract is what is the overall goal of the project itself, and that's a summary from beginning to end. So a paragraph from beginning to end about your entire project, which basically tells them what the poster is going to tell you from beginning to end. So in one paragraph. And then you start with your background information and then your methods. Your methods being what have you tried, what's worked. You can also include things that don't work. I've seen that as well, because if you're in the stage of preparation or you're at the beginning of the stage, you don't actually know what's going to get to your final answer, especially if you're in the PhD stage. But you can show what doesn't work and why is that good, because then that gives you motivation for your actual conclusion. Because your conclusion is going to say, well, this is not a good method for this, for instance, for this data, and we can show why it's not a good method for this specific data that I'm studying. And that's just one example, but contradictions and things of that nature that may disprove your proof if you're in pure math. Right? So then you get to your results, and again, you don't have to have results. That can also be a discussion section, but that's on that last column, and then conclude with what you have done and with your future work and what you plan to do. That's always good for any poster session, because you will get bigger ideas. And so, not bigger, I was looking at things, but you will get more ideas from those who actually come by, because you don't know what areas they may be in. They may look at your project and think a completely different direction than you've been thinking. So that's one of the good things about poster sessions, is that you have a lot of space for input and generating new ideas to actually get to different conclusions that you may not have thought of. Content, I think I mentioned most of this. So this is leaving out smaller details, focusing on the big picture. You don't want to have an entire proof on your poster, but maybe a pseudocode, or if you have something that's very computational, maybe you do have the beginning of a proof and then the end of a proof, but then maybe you talk about what you used in between to get to that proof, and things of that nature. But you want to stick to your big, leaving out the smaller details, put your big picture ideas on the poster, and then talk about everything in between. Bullet points are usually good, because that just helps the reader follow along, as opposed to paragraphs. But short paragraphs are usually acceptable, so that the reader does have some context, some full context about what you're stating. Especially if it's like something that's known, like a theorem or something of that nature, and what it's used for usually. And you can talk about what is different in your research from what's known. So if you are going to attend the Math for All conference, and I hope you all do, you can submit it to us and we'll print it for you, so you don't, there's no cost associated with that. A lot of times, poster sessions at conferences will offer the same thing, so especially for students, undergrad and grad students. So make sure you look out for those opportunities, and then also try and print at your university beforehand. That can help you out a lot. So now some students who wait till the last minute, then they're in California trying to figure out how to print their poster at another Staples or something like that. So don't do that. But again, we can print them for you here, and then just be on the lookout for that when you apply for conferences, to give talks at conferences. All right, so how do you actually design it? There are plenty of templates out there, so you do not have to just open PowerPoint or LaTeX and start from scratch and make your entire presentation. So LaTeX and Overleaf are things that you can search. Overleaf is, if you're not familiar with that, that is online version of LaTeX. So you can type in mathematics equations a lot easier. And there is a formatting that you have to learn, but it's not too complicated if you already have a template, because you can just change the words in there and then Google everything else that you need. But if you search, really just put in Google Overleaf poster template, and you will get a bunch of different templates. You can change the colors to Clemson colors, because usually, yes, when you do a poster presentation, you're also advertising for your institution and the kind of research that Clemson is doing, the School of Math and Stats. So you want to make sure you have a Clemson logo, Clemson colors, all of that on your poster. And then there's also PowerPoint templates as well. So you can put in Google PowerPoint poster template, and that will give you the same thing. So I've used both, different things for different purposes. I started, I think, some in Overleaf, or usually if I'm gonna end up with a lot of equations or a lot of algorithms, I tend to use Overleaf, because again, I can put in mathematical symbols easier than on PowerPoint. But if I'm using PowerPoint, this is more for an applied audience. If I have a lot of figures, or if I have, I deal with data a lot, and so I have microscopic images, and I just need to post pictures, and that's sometimes more difficult to do on Overleaf just because of the formatting, and you have to get the spacing right. So I tend to use PowerPoint for if I'm going to have a lot of images and I don't need as much math text in my presentation. But another cheat code, you can combine the two. So if you don't like Overleaf, just use the PowerPoint one. Type your math equations on Overleaf and screenshot them and put them on your PowerPoint. So that is also a cheat code, just if you're having trouble with formatting. So I've seen people do that as well. Just make sure everything is the same size and you should read it. But again, there are templates there for you to try, and again, you don't have to do this from scratch. All right, so pretending you're now the poster. So this is my poster. It wouldn't be this big, but I'm standing and people are walking over to me and saying, hey, so can you tell me about your research? It's usually a very broad question that they ask. They don't usually ask something too pointed until you start talking about what you're doing. But you always want to start with your name, right? This is also not only an opportunity for you to share your research, but to network. And so people can find out what you're doing. They can tell you about grad programs if you're an undergrad. They can tell you about postdocs or faculty positions if you're a grad student. And same for postdocs and faculty, just other opportunities that you may be interested in. But always start with your name. Say your institution as well, or mention it, because it should be on your poster as well. And tell them what year you are in school, because that will help them tell you what programs you can apply to at your current stage. And then tell them, who your mentors or your collaborators are. You also want to make sure you have that on your poster as well. So you're the one presenting it, so you should be the first name on your poster. But then after that, comma, list your collaborators, list your faculty mentor, all of the above. And that will also help. Maybe they've worked with someone. You never know. There could be overlap. You could, just mentioning. I'll just mention, for instance, my postdoc mentor, Scott McKinley. I mentioned his name during a poster presentation, and it happened that who the person who was talking to me was his main collaborator, and I didn't know their face before. So just putting two and two together, that helps when you're giving a poster presentation, because you just don't know who you may be talking to. And that helped during the entire presentation, because then I knew that they already knew about my research, so I didn't have to explain everything from scratch. I could actually talk in a more pointed manner to that person. But that's all in your pitch. So who are you talking to? Then talking about the question. So the question and the problem is the main purpose of your poster. And phenomenon that you're working with. So I mentioned that for more applied people. If you're not in math specifically, it may be a phenomenon that you're trying to study. But then talking about your methods, what did you use? What conclusions did you find? And then also don't be afraid to mention what you're excited about, because as long as you're excited about it, get nerdy with it like I put on here. But as long as you're excited about it, other people will be excited too. You can get them excited to give you ideas, or maybe end up being collaborators because you're generating questions that will help both of you. You want to make sure you leave out, reciting formulas and everything, detailed explanations. I talked about that a little bit earlier, but nothing that's super advanced, because that's going to take too much time to get to the point of your poster, which is a general summary and overview of your work. And so, yes, it says opening remarks / pitch, but this is not necessarily talking about your whole poster at once. This is just a short summary at the beginning. And then the person that you're speaking with will usually guide you in the way that they're most interested in. Some people are like, oh, well, actually, I want you to walk through the whole poster. So you can do that. And some people are like, oh, okay, well, I read your poster earlier. I walked through the posters and I read it, but I'm just interested in this main result, or I'm just interested in your method. So you want to start with your summary and then give the person the opportunity to ask what they would like you to share about your work. So I mentioned this a little bit earlier, but how to get your poster around. Bring water, because you will be talking a lot, and you'll just be standing there for 45 minutes talking to everyone. So make sure that you have some water. You bring some water with you. Stay hydrated. And if you are moving around, so I mentioned that you'll have time to stand by your poster. That's usually required for a specific time period, and then you can walk around. So if you do see a bunch of people by your poster during that time, just you can always run back over and say, hey, this is my poster. Did you have any questions? And then if not, if they do, you can stay. If not, then you can go back and observe other posters as well. Because again, it's still an opportunity for you to meet other people in that space. Here are a couple of conferences that are starting with undergraduate, and then of course graduate students can usually apply to the joint math meetings, research symposium, obviously all the ones that are not undergrad related, but undergrads, I wanted to make sure that you know that you can also present at these as well. So undergrads and grad students for all of these conferences. Some of them have programs that are built in, for instance, like U-Stars, I believe. I can't remember where it's hosted right now, but you may or may not have heard of some of these. So this is just a good list of possibilities. I put Siam specifically, Southeast, Atlantic. Yeah, that's our section here at Clemson. So there are sections of your main organizations, if you're not familiar. So SIAM is the main organization, and then sections which are regionally based. And so you'll just be at this conference with people in South Carolina, I think it's Georgia, Florida, in that area. But then the main SIAM, that'll be anyone from around the world. So that's a more international. Yeah. Anyone in the audience see any or don't see any that are good that I haven't mentioned? So it'd be a good opportunity to get you all involved. All right. Yeah, so this is just, again, just a list. You want to check, if you do go to any of these, you just want to check when they are, because all of these can be happening at any time of the year. Some are in the summer and some can be next week. So you just want to make sure that when you are looking for a conference to present at, you're looking at least 6 months in advance, because the deadlines for submission are usually way ahead of the actual conference. And then you also want to make sure you have enough time to prepare your poster and then get some research work, have some progress before that presentation. So I would say about 6 months ahead. So I guess before I do that, any questions? So here's just a couple of examples, and I know you can't read it here, but this one is geometry. So I'm looking at it like this because this is not my area, but this is geometry. And what they started with was a proof. And I remember this is a faculty member at Tulane, Kalina Mincheva. So she was assistant professor at the time. And, you know, she's done this research for a while. And so her goal on this poster was to compare results from different theorems and definitions that she studied in relation to this theorem here that was the most important on the very last column. And I don't think I mentioned references. You do want to make sure you include references. I know when you're doing research, you have way more than 2 references that you use, but the main references need to be included. So it's usually about 2 to 3 references on your poster, just so that anyone who's coming by, and if you already published a paper that's related to this, and you want to advertise it, also put that in your references as well. But the main references for your work, and actually I mentioned that because Kalina, this is one of her papers that she made sure to reference because she's assistant professor at this time, so she wanted to make sure that that paper is known, that work is known. And so that was her goal for this poster. And then this one is a more applied topic, so differential equations, PDEs, it looks like. And so they were studying quantum systems, and this was a graduate student at Tulane at the time, so Robert Johnston, sorry. But again, starting with a short abstract to give you a general idea of what he's trying to do. So proving existence of solutions was the main goal for this poster. So starting with the introduction section, and a nice figure to say, well, this is what quantum entablements look like, and this is what we're dealing with from the mathematical perspective, and then breaking down the work that was done in terms of setting up your equations, your systems of equation, your mechanics, your quantum mechanics here, and the theory behind some of the sets of equations and why they're necessary for this work. References are moved here, so references just need to be somewhere on the bottom. It doesn't matter what column usually, but just somewhere at the bottom. And then over here on the last column, having some solutions that he was able to solve at this time, and then actual visual representation of what these equations were telling you. And when you do include figures, you just want to make sure that it's readable in terms of, you know, you have your figure, and then it has in his case, he has the equation that is related to each figure underneath, and then your parameters are clearly labeled as well. So all that to say that if you do have figures, you want to make sure that if you're not there, people can understand what that figure is telling you on their own. And then he ended with some acknowledgements because, again, he was a PhD student at the time, and so still working on this. But only thing he's left out here was maybe also including your advisor at the top, because they're doing this work with you. So this was actually one of my students at the time. So she was an undergrad and just getting started with math research, and she was trying to decide really, did she want to go to grad school or did she want to go to industry? And so she said, well, I really like what class is that? Differential equations, so DE2, second part of differential equations. And she's like, well, what can we do? And so she really liked cats. And again, this is not anywhere near my research. I do not study cats, but population modeling is what I do know how to do. And so she's like, well, I would like to model the population of feral cats in New Orleans, because New Orleans has a lot of feral cats. And so that was the undergraduate research project. And come to find out, after looking up, some background information, there are studies with, not mathematical, but with veterinarians on just collecting data for these populations, but they didn't actually do anything with the data. They just kind of look at it every year and just see how many there are. And so she was able to build some models using systems of differential equations here in the bottom. And instead of, these are not equations, these are labels of parameters, but instead of listing out the equations, making them a diagram instead, since that would be a lot of equations, focusing on simulations in her case, simulating possibilities, different outcomes based on different possible sets of parameters, given the data that she had. And then what does she observe for each scenario, and then future work if she was to continue this work. But yeah, so that was an undergrad research example. So again, didn't have to be super complex in terms of the topic, but how, in her case, how can I use my differential equations undergrad course and apply it into something? And I think this is the last example. So this was a faculty member, I believe. Yeah, this was a faculty member. And again, this is a more applied poster. And so they were very heavy data analysis. And so I wanted to include one of each type of poster presentation here. And so they were studying Ukrainian children, risk factors. I can't remember exactly, but risk factors for body burden in Ukrainian children. But again, this is very data science heavy, so they wanted to make sure they included maps and where the data is coming from. And so spending a lot of time in your introduction section talking about this data, what the data says, what you're able to extract from the data, what methods did we use or develop to understand this data better and the process that they're interested in. Results, again, they're going to be figures in this case, because you have data, you want to understand how to summarize that data just by looking at a figure and saying, well, if I have this data set, this is what we can say about this set of data. And then in this case, discussion questions based on what they were able to accomplish, and conclusions and acknowledgements and references as well. And so that's what I wanted to mention. But again, don't be scared to make a poster. It's the best and the easiest first start at research. So anytime you have the opportunity to do a poster session, especially in the beginning, definitely go for that. You do not have to have research experience. I want to make sure I repeat that, because this is, especially if you do the Math for All conference, this is your introduction. So learn the tips here at Clemson before we send you out somewhere else, right? You do not have to have made a poster before. You don't have to know what your poster will be about. Again, like I said, Abigail did not. She just said, I like to study feral cats, and we figured out what we could do with that. You don't have to have public speaking experience. This will come from experience. This is your first experience, so that's checking that box. And also, if you're new to the math major, or I can say math program, if you're a master's student or a PhD student, but if you're new, you can always make a poster as well. You have something to talk about. Okay, so that's all I have for you today. Here's some links. So some of the references and resources that I mentioned are on this link, and our email list if you want to add for the Math for All conference that'll be here. So I'll be sending out information, and Dr. Carter, she is also another faculty member that's part of this conference with me. And then you may or may not know Lauren Henderson, who is a grad student here, and Miller Kristen, who's an undergrad here. So also feel free to reach out to them if you have questions about any of these things. I think they have all done a poster before. And we'll also be able to talk about the conference, the Math for All conference. So Thank you, and let me know if you have any questions.
Questions? Well, let's thank Dr. Cook once again. Somebody else out there had a question earlier.
They're still there. If you're online, are there any questions?
Thank you so much. Well, everybody knows the rules of back club. All pizza's gotta be on, so. Let's see how you all have done.